beautiful people, and welcome. In this video, we are talking about graphing exponential functions. Now, this is a part 2 video. In part 1, we talked about all the information that you need, the formula that you need for exponential functions. In this video, we are only doing examples. I'm going to show you 2 examples for a continuous exponential function, and I'm going to show you an example for a discrete exponential function. I'm actually going to show you 2 examples per continuous and discrete. As always, if I make a mistake, I am human. Please let me know where the mistake occurs so that way I may learn from it. All right, let's go ahead and jump in. I'm going to go ahead and rewrite the formula here, just so that way you can have it as y or f of x. It doesn't matter. The higher in math you go, the less you use y. So if you want to use y here, you can. But you need to know what it is. Okay. One thing we pointed out in our part 1 video is that k is going to be our asymptote of y equals k. Our asymptote is the line that shall not be touched. So it's not crossed, it's not touched. And that's going to be after, sometimes you can see it before, it's whatever you are adding or subtracting. So whatever you're adding or subtracting, that's going to be your asymptote. So let's look here. Starting with a continuous exponential function. Here's 2 times 1/3 x. So I'm going to add a plus k. That plus k is not there, right? So that means your asymptote is y equals 0. That means the line that shall not be touched is y equals 0. So here's our y-axis. You're going to find where 0 is, and that's your origin. So here's 0. And y equals 0, it looks weird. You're actually kind of doing the opposite. So you're going to think you go up and down, but you don't want that. You're going to do a horizontal asymptote. So I'm going to highlight it here. Here's your horizontal asymptote. We cannot touch that. Looking at the function, if you're in integrated math 3 with me, you know that the function is going to be an increasing function, or is it going to be a decreasing function? Ooh, let's think about this. I was going to say something else, but then my mind went where it's supposed to go. Let's talk about here. Here are the notes from part 1. If the base is greater than 1, we have exponential growth. If the base is smaller than 1, we have exponential decay. So let's look at our b value. Here's our base. So our base is smaller than 1. And what does that mean? That means that we're going to have a decreasing function. So now in my head, I'm thinking it's going to look something like this. This decreasing function is going to look somewhere down here because I know I'm not going to be able to cross this line. And so now what's happening with the 2? This is what you're going to do to solve this dilemma of graphing. You're going to make a t-chart, and you're kind of going to make a pretty large t-chart. You're going to make a small one here. This is going to be your x. Here's going to be your work, and here's going to be your y. Now, obviously, at home, you can sometimes use a calculator. Sometimes in class, I know in Integrated Math 1 for sure, they don't allow you to use calculators. So just be mindful. I'm going to show you the work, but if you're at home, just use a calculator. All right. So what you're going to do is, because this is continuous, the domain is not given. So you can choose whatever you want for your x values. Typical rule is you want 2 negatives, 2 positives, and a 0. That's typical. So let's do 2 negatives. Now you want to choose pretty points. Don't choose negative 37. You can, you have my blessing, but I don't want to deal with that. So I'm choosing happy numbers. I'm choosing pretty numbers. The smaller numbers that I can. Now you can choose a fraction if you want. I don't recommend it because fractions and in exponents just complicate things a whole ton. It means something completely different. So for your work, you're going to copy down your equation. And I'm going to copy it down without the y, just to save some space. And here's 2, 1/3. And instead of writing x, I'm going to write my new x value. So negative 2 is here. I'm going to keep doing that for all of them. And then if obviously, I did too many parentheses, that's okay. I can save it. It doesn't matter that one. So I have negative 2, negative 1, 0, 1, and 2. So now you're going to evaluate first and always first your exponential value. So what that means is you're going to evaluate this. Evaluate this first, evaluate this first, evaluate this first, and evaluate this first. I always like to start with the easy ones, 0 and 1, because anything to the 0 power is 1. So let me actually change my number. I'm going to say 2 times 2 times 2 times 2 times 2, and I'm going to put parentheses because I'm going to be evaluating these things. So I'm starting with 0, the exponent in 0. 1/3 to the 0 power is 1, and then 2 times 1 is 2. I'm also going to do this one first as well because anything to the first power is that anything. So I have my 1/3 here. Excuse me. 2 times 1/3, that is 2/3. Now I'm going to go back and kind of figure stuff out here. This is 2 to 1/3. I'm going to choose to do my positive values first. That means I have 1/3 times 1/3. The exponent is 2, so that means I write my base twice. So that means I have 2 times 1/9. And that means I have 2/2. I said 2/2. Get it, 2/2? It's not 2/2. It's 2/9. And then let's go back up here to the negatives. Now, we actually like negatives when the base is smaller than 1 because it gets rid of the fractions sometimes. So here is my negative 1. Remember, to get rid of a negative exponent, you flip the fraction, remove the negative. So we're going to flip the fraction, remove the negative. I still keep the exponent, however, I am removing the negative. So that means I get 2 times 3 to the first power. That means 3 to the first power is 3. 3 times 2 is 6. And now we're doing the same thing for this one. Flip the fraction, remove the negative. So that means I get 2 times 3 times 3. 3 times 3 is 9. 9 times 2 is 18. Once you are here, these are your input values. These are your output values. So here's input, here's output. So if my input is -2, let me actually highlight the X and Y axis because I feel like you can't really see it. And remember that one with the green, that's our asymptote, right? This is our asymptote because we did not have a K, our asymptote is here. All right, so let me actually, you know what? I'm going to, no, that's okay. So you guys should have this on your sheet of paper. So when I'm graphing, you should graph with me. So here's -2. -2 is on my X here, and then I have 18 as my Y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my 18, I'm running out of space. That's okay, because do you see this arrow? It means it continues. So if this is 10 and I need